All right, so this is the last gas law. It's called the combined gas law, and shockingly enough, it is because it's a relationship between pressure, volume, and temperature. So now you have all three together. So this is the equation. P1 V1 divided by T1 equals P2 V2 divided by T2. Once again, all the ones represent the original or the initial pressure, volume, temperature. The twos represent the new, the final. And just quickly to show you, let me see if I can get the whiteboard here. Okay, you have P1 V1 over T1 equals P2 V2 over T2. This is kind of like stoichiometry. If you knew mass to mass, you knew all four conversions. If you can memorize the combined gas law, you know all the gas laws except Dalton's because it's not included in this. So, am I in a color? Okay. If you go for the top, P1 V1 equals P2 V2. That's Boyle's. Guess I ran out of room. If you go P1 over T1 equals P2 over T2, that's Gay-Lussac's. If you go V1 over T1 is equal to V2 over T2, that's Charles. So right there, you have all three gas laws plus the combined gas law. The only one you don't is Dalton's. So like I said, if you can memorize this one and know how to break it apart like that, you have all the gas laws except Dalton's right there. Kind of interesting. Okay, back to this. Let's actually try a problem. So I'm going to highlight all the important stuff first. A helium balloon has a volume of 50 liters at 25 degrees Celsius and 1.08 ATM. What volume will it have at 0.855 ATM and 10 degrees Celsius? So just like before, I like to make a list. That's up to you. Now I've got 6 variables, 5 of which are given to me. P1, V1, T1, P2, V2, T2. Pressure still has to be in atmospheres. Volume still has to be in liters or milliliters. Doesn't matter as long as you're consistent. And temperature has to be in Kelvin. So we're finding V2. Okay. Oops. So I have P1, V1 over T1, P2 times V2 over T2. Now, just because I'm doing it my way doesn't mean there's other ways you can do it. There doesn't mean there aren't other ways you can do it. So feel free to do whatever method you're using as long as you show your work and you get the answer. If you'd like to cross multiply, you can set it up in a straight line like this. It's up to you. I'm going to use this method just to kind of show you, but like I said, do whatever works for you. So we're finding V2. So we're going to divide both sides by P2 and T1. Using parentheses will come of importance here. So V2 equals P1 V1 T2 all over P2 T1, or however you chose to set it up. So don't forget units. I have pressure, initial pressure, times initial volume, times initial Kelvin temperature, all divided by the new final pressure and the new Kelvin temperature. If it wasn't in the correct units, I would obviously have to convert before I could actually do the problem. So 1.08 times 50 times 298, all divided by the combination of 0.855 times 283. And I got V2 equals 60 liters. If you didn't get that, I would try throwing some parentheses at least around the bottom. Okay? You can put it back into the original equation. Both sides should equal each other. It'd be very close. Combined gas law. Let's try another. A volume of gas is 27.5 milliliters at 22 degrees Celsius and 0.974 atm. What will the volume be at 15 degrees Celsius and 0.993 atm? This is very similar to one we just did. So I've got P1, V1, T1, but I have to change that to Kelvin, I'm finding V2, whoops, I don't know what I did. Oh, I have captions now. Interesting. Oh, I don't have captions anymore. Okay. So we're finding V2. We have to change T2 to okay. So once again, you're using P1 times V1 divided by T1 equals P2 times V2 divided by T2. Use whatever method you want, but if you're cross multiplying, P1 V1 T2 equals P2 V2 T1. Once again, solving for V2. So you're going to divide both sides by P2 and T1. So V2, that's going to cancel. V2 equals P1 times V1 times T2, all divided by P2 times T1. Like I said, if you're not getting the right answer, I would try at least throwing some parentheses around the bottom. So try that in your calculator. Pause the video if you don't want a spoiler alert. I got V2 to equal 26.3 milliliters. Okay, so doesn't matter what you're solving for. You're always going to have 5 variables out of the 6, and you just have to algebraically rearrange and solve for the unknown. That is the combined gas law. P1 times V1 divided by T1 equals P2 times T2 divided by, I don't know what I just said. Let's start over. P1 times V1 divided by T1 equals P2 times V2 divided by T2. I think you got it right that time. Okay, and that's it. That's the end of chapter 10, gas laws.